Okay, welcome back to section 5.5. Remember last time we were talking about solving polynomial equations, and we talked a lot about the different kinds of factoring, and then at the end we said, okay, well if I'm going to solve, like we did in these real-world examples with the geometry cubes, we take our polynomial and we factor it down, however that looks like. Sometimes we have lots of factors, but as long as it's equal to 0, then I can take each factor and set it equal to 0, and solve my polynomial that way. That's one way to solve polynomials. So that involves knowing all of that sum and difference of cubes and all of the different factoring formulas that you are already supposed to know back from chapter 4. So today we're going to finish section 5 by talking about something else, which is called quadratic form. So quadratic form is basically if a polynomial is in quadratic form, then I can use quadratic techniques to solve it. So maybe I could factor using quadratic trinomials, or I could do completing the square, or I could do quadratic formula, things like that, if it's in quadratic form. So it might not be quadratic, because quadratic means that the highest degree is 2, but it might be in quadratic form. Quadratic form means that I can write my expression like this. So I have a, but instead of x squared, I have u squared here and u here. And u is just some expression in x. So instead of just having x squared, I might have x to the 4th squared, or x plus 1 squared, or x minus 7 squared. But the key is that whatever is being squared right here has to be the same to the first power right here. So for example, let's look at this one. 12x to the 6th plus 8x to the 6th plus 1. I don't think they did this right. And so continues the saga of finding typos in the PowerPoints. Okay, so 12x to the 6th plus 8x cubed plus 1. We're going to ignore this for a second. So here, can I write 12x squared as something squared, right? Can I have a coefficient times something squared? So there's actually a couple ways I could think about this. Think about this as 12 times x cubed quantity squared. X cubed squared is x to the 6th, plus 8 times x cubed plus 1. So in this case, my u is x cubed. So here I have u squared, and here I have u to the first power. So as long as this matches this, and this is being squared, and this is to the first power, then this is in quadratic form. Another way that we could think of this is I would be able to write 12x to the 6th as 3 times 4x to the 6th, and I could rewrite 8x cubed as 4 times 2x cubed, and then I have the plus 1. So you might be thinking, why are you doing this? Well, 4x to the 6th is 2x squared, sorry, got that backwards, 2x cubed quantity squared. So this is the same as 4x to the 6th, and then it's just times 3, plus 4 times 2x cubed plus 1. So this way, my u in this case is 2x cubed. So I have an expression here, 2x cubed, that's squared, and here I have an expression to the first power. So anytime I can rewrite an expression like this, where here I have some expression squared and here to the first power, and then a constant, then it's in quadratic form. Okay, so let's take a look at this one. 2x to the 6th minus x cubed plus 9. We're going to write this in quadratic form if we can. So let's take a look. First, I take what's in my first term and see if I can rewrite it as something squared. So in this case, 2 will be my coefficient, and x cubed squared is x to the 6th. So x to the 6th can be rewritten as x cubed quantity squared. Minus, then I'm looking to see if that matches this x cubed, and it does. This is x cubed to the first plus 1. So this matches. I basically have 2u squared minus u plus 9, where my u is x cubed. So I have a coefficient times an expression squared minus a coefficient times that same expression to the first power plus 9. So this is quadratic form. Okay, let's take a look at this one. X to the 4th minus x cubed minus 1. This cannot be written in quadratic form. Why? Well, x to the 4th can be rewritten as x squared squared, right? But the problem is here that x cubed to the first these don't match. What I'm taking to the first power does not match what I'm squaring, right? This middle, whatever my expression here is in my middle term, x cubed, when I square it, it would have to give me my first term, x to the fourth. Just like when we looked at the previous example, x cubed squared is x to the sixth. So that works for quadratic form. In this case, x cubed squared would be x to the sixth, not x to the fourth. So this cannot be written in quadratic form. Okay, so you guys try this one. All right, your answer here should be C. X to the 10th is x to the 5th squared, and then in the middle I have x to the 5th to the 1st. So that works in quadratic form. Try this one. This one cannot be written in quadratic form because x cubed squared would be x to the 6th. So if I rewrite x to the 8th as x to the 4th squared, that's not going to match what it needs to match here, so that it would be quadratic form. What I'm squaring here is not what is being taken to the first power here. All right, last but not least, that was just writing things in quadratic form. Now we're going to look at how that helps us to solve quadratic equations. Okay, so here I have x to the 4th minus 29x squared plus 100 equals 0. In chapter 4, we would have said, well, we don't really know how to solve this because it's not quadratic. We can't do quadratic formula or factor, but actually with this we can. So we're going to start by rewriting it in quadratic form, right? X squared squared minus 29x squared plus 100. And then something that makes this a little bit easier is if you take whatever your expression is here that you're squaring, that's the same as this expression that's to the first power, and you do this. You're going to replace it with u. So u is going to be the same as x squared. And this is going to make life easier when you're doing the solving. So we're going to replace x squared with u. So this is u squared minus 29u plus 100. And now this equation looks just like the quadratic equations we've solved before, which is a big benefit because now you can either complete the square, quadratic formula, or you can factor. In this case, factoring is the fastest. Two numbers that multiply to positive 100 but add up to negative 29, negative 25, and negative 4. Since the leading coefficient is 1, we don't have to do the grouping part. And then we set each of those factors equal to 0. If you don't remember how we got from one step to the next, we do u minus 25 equals 0, or u minus 4 equals 0, and then you solve. So I get u equals 25 or u equals 4. But we're not solving for u, we're solving for x. So now I'm just going to replace my u. I know that u is the same as x squared. So I'm going to say, okay, x squared equals 25, or x squared equals 4. And then when I solve that, I get x equals plus or minus the square root of 25, or plus or minus the square root of 4. In this case, both of those are perfect squares, so I have x equals plus or minus 5, or x equals plus or minus 2. So this equation has roots at positive 5, negative 5, positive 2, and negative 2, meaning that it would cross the x-axis at 4 different points: 5, 0, negative 5, 0, 2, 0, and negative 2, 0. Interestingly enough, notice that the original degree of the equation is 4, and I ended up with 4 solutions. That will always happen. All right, so now I want you guys to try one. Try this one. Okay, your answer here should be A, and I'll show you the work. So here's the work for this problem. Notice that I wrote it in quadratic form first, so I have x cubed squared minus 35 times x cubed. And then I did the substitution of letting u be x cubed. So this will make it a little easier to solve as a quadratic. So u squared minus 35u plus 216. Then in this case, again, I could factor. So I have u minus 8 equals 0, or u minus 27 equals 0. So I get u equals 8, or u equals 27. But remember that u is x cubed. So how do I isolate x if x is cubed? Well, I do the inverse operation, which is the cube root. Notice I do not have to do plus or minus with a cube root because I can have cube roots of positive and negative numbers. So only positive 2 cubed is going to give me 8, not negative 2 cubed. Negative 2 cubed would give me negative 8. So with cube roots or any odd index root, I don't have to do plus or minus. So here I just get x equals 2 or x equals 3. And now you're probably saying, but the degree is 6 and you said that there will always be the same number of solutions as the degree, and that is true. Here we have 2 real solutions. That means the other 4 solutions would be imaginary in this case. The other 4 solutions would be imaginary or complex numbers. So this equation, this polynomial, is only going to cross the x-axis twice at x equals 2 and x equals 3. The other 4 roots would be complex roots, so they would not cross the x-axis at those points. All right, that is the end of this section. I will see you in class to practice.